Good evening, everyone. Am I audible?
Good evening, Vijay.
Yeah. So today is just going to be a doubt session. So if you guys have any doubts, then feel free to, uh, you know, unmute yourself and say it. And I believe today is your C programming week 5 deadline, right?
Yes, Vijay.
Okay. So should we just, if you guys have any doubts, then let's just take them right now. So shall we start from the practice assignment? I'll just share my screen in that case. So is my screen visible?
Yes.
Okay. So this is a practice assignment. Since the deadline is not out yet, for obvious reasons, we cannot, discuss the graded assignment solutions. But yeah, it's quite simple indeed. But yeah, so if you have any doubts, then just post it in the chat or unmute yourself. You can speak at any time. Uh, let's just start off with this one. Is this visible now? Okay. So the first problem, let's just get started. What is the scope of the variable a declared inside the if block? So can anyone just tell me what scope means? Anyone? Okay, so have you guys figured out what scope means here? Am I audible? And is my screen visible?
Yes,
Yes, sir.
Okay.
yes, sir.
So first of all, can anyone tell me what will happen if I, like, let's say print a outside of this if block? Let's just take it over here and do it. Okay, so we have this code right here. So can anyone tell me what will happen if I print this inside the if statement?
It will work within the if statement.
Like, what will the output be? What will the output be for this one? So we are getting the output as 5. Okay, so that much is expected. Now if we just take this one, print this outside here, now what will happen? So can you tell me what went wrong?
And the print statement doesn't work out and out of the if block because we haven't declared any function a before the if block.
I mean, yeah. So we have declared it inside the if block. So this variable a only has it only has meaning within this if block. If we were to call it outside, then it wouldn't really matter. So what what will happen if I just do int a equals, let's say, 10, and now I print this over here? What will the output be? I'll just remove this one. So now what will the output be?
10.
Okay, so let's just see. The answer is 5. So the reason is, one second. Okay, sorry about that. But yeah, the reason that this happened is because we had declared it outside of this one, but we updated it within the loop, within the condition. One second. Previous term quiz questions. I'll have to find those out right now. But yeah, we can do that. So, do we have any classes before quiz? Like today's 20 sorry, today's 19th. I believe 21st we have a class, and 23rd also we have a class. Although 23rd probably it will be cancelled because of quiz. So we have one last class tomorrow. Sorry, day after tomorrow. Um, okay, yeah, sure. Let's just. Are we going to summarize session for qualifiers? I'm
Your voice is breaking.
Am I back?
Yes.
Yes.
Okay. So just give me a second. I'll bring out the old courses. Yeah, I guess there's some network issue going on my end. But yeah. So yeah, this is the page. I'll just I'll just bring the questions over here so that we can practice it properly. So we have just one second. I'll bring it out. Summary live session for qualifiers. I'm not really sure about that. Like the instructors should, like ideally, the instructors should be conducting that one. But yeah. Uh, just give me a second. I'm trying to find some PYQs. Okay, so yeah, we got mock questions. So I'll just open my journal. So this is the first question, and these are the options. Just one second. Is my voice clear now?
Yes.
Okay. Okay, so these are the qualify exams, I guess. Yeah, these should be fine. Um, yeah, so this is the first question that we have. Let R0 be a register and M0 be a memory location. Consider following two instructions. R0, so M of R0 to R0 and R0 to M0. So what is the correct statement in this one? Instruction 1 is a load, whereas instruction 2 is a store. Both are Okay, so can you guys just tell me the definition of loading?
Taking something out of some box, like
Okay, no. So in the case of computer science, which this course is technically part of computer science, but yeah, whenever we are referring to loading in computer science, we mean to say that we some data that is on some register or some RAM. In that case, it would be considered as loading data onto a RAM or a register. And this is from a register to a memory location. So whatever data was in R0, we are taking that in R0, and we are storing that in R0. So whatever data that's on some RAM or some register, and we are storing it or copying the data from the register into the memory location. So one thing that I want to make clear is that both of these are copying information. Okay, so these are both simply just copying. This is copying from a memory location to a register, and this is from a register to a memory location, right? So with the definitions that I just told, uh, which one of these is a load operation and one of this is a store operation. So can anyone tell me which one is load and which one is store?
the first one is load and second one is store.
Correct. So the reason why the first one is load and the second one is store is because in the first one we are taking the memory location. So whatever data was in R0, we are taking the memory of that location. So let's say in R0 we had 0. So whatever is in memory location 0, we are storing that in R0 now. And in the second operation, we are taking whatever data is in R0 and we are storing that in memory location 0. So in the first one, we are copying some value into the register. So this is an example of loading. And in the second one, we are taking data from a register and copying it into some memory location. So just one second. I'm experiencing network issues, so I apologize for that. Yeah, I believe that it's the network in IIT Madras. I've reconnected a few times till now. Okay, just one second. I'm finding the questions in C programming for this one. Yeah. Okay, so I'll just ask these as normal questions. I request that the people who have already seen the question paper do not use it, but try to answer this on your own so that we can all learn better. And for this one, please just raise your hand and I'll ask you to answer. So, which component of the CPU is responsible for carrying out arithmetic and logical operations? Can anyone can anyone tell me without any options? Okay, Ram, you have raised your hand.
It's
So can you
ALU.
answer? That's right. So any arithmetic or logic operation that is performed by a CPU, it is carried out by the ALU or arithmetic and logical operation, the arithmetic and logical unit. Okay, so I guess that was a pretty self-explanatory question. So the next one is, what is what is the primary purpose of cache memory in the CPU architecture? Can anyone answer this without options? Okay, so I'll just provide options. To increase the available main memory, to provide a storage space for operating system, to manage data flow between input and output devices, to speed up access to frequently used data and instructions.
To speed up frequency to get speed data.
Okay, so that's the correct answer, Mohit. But please raise your hand the next time. Okay, and Bangaru Akhil, you also got the correct answer. So good job on that one. Um, okay, so the next question: what's the minimum number of arithmetic operations required to compute the value uh, 2x cube plus 4y plus z square plus 5 in a CPU which can only perform addition and multiplication? So I'll just copy the question so that it's more easily visible. But yeah, I don't think that I need to give any options for this one. So just try to figure this out, and yeah, just raise your hand when you feel like you can answer. Okay, Sayed, you have finished.
Eight.
So you are selling 8.
Yes, sir.
Okay, so let's just see if that's correct. Firstly, there's a multiplication over here and 3 multiplications over here. So we already have 4 over here, and we have an addition over here. So that's 5. After that, we have another multiplication over here. So that's 6. Another addition. So that's 7. And then we have another multiplication over here. So another 2 in that one. Right. Sorry. So I just miscounted this one. So this is one multiplication, and these are two other multiplications. I hope you can see why. Yeah. So it is essentially like 3, and then we have an addition over here. So 4. This is a multiplication. So 5. Then addition 6. Multiplication 7. And finally, this is addition. So this is 8. So yes, 8 is the correct answer. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, that's correct. So actually, in the answer sheet, it's marked as wrong. So that's why I wanted to calculate it manually. It's marked as 7 is the correct answer. But don't worry, you'll even if there are some errors in the marking scheme, you'll get the correct. Um you can dispute it, and yeah, you'll get the correct number of marks. Uh, how does the CPU can understand linear equations with exponents? Honestly speaking, the CPU does not really understand exponents. It does not even really understand multiplication unless you have like a specific, circuit made for multiplication. So how it works is that it simply just loops. Okay, so you may know that addition is just like addition is a basic function, and from addition you can get multiplication. right? And multiplication is essentially just repeated addition. So after that, repeated multiplication is exponentiation, right? So you can simply just emulate it using loops. If you know how many times you want to, exponentiate, then you can just simply, you know, r- multiply it repeatedly that many times. Simply add the number as many times as you need to multiply it, and then multiply it by itself until you get the needed exponents. So that way, this whole equation, it really just needs addition to function properly. Is that clear? Okay. Uh, Mohit, in order to calculate this, it's actually like quite simple. Uh, in the chat box, like Ram has expanded this into the form that we are using to calculate this. So we have this form right here. So as you can see over here, we want to count how many operations we need to you know calculate this one using a CPU. So we only want to consider this and this, the addition and multiplication. So if we do that, then we get 1, 2, 3, 4, 5, 6, 7, and 8.
Okay, so we just only need to simplify it.
Right? The equation in the form where it only uses these two operations. Is that okay, Mohit?
Yes.
Okay. So then the next question, the 16-bit, I'll just copy this over here. Okay, assemble numbers. Okay, so can you guys just try to work this out? I won't be giving any hints for this one. Okay, so has anyone solved it yet?
Yes, sir.
Okay, so Can you just give me what you got? Like, can you give me the number that you got? Okay, so this is the reference number that we have. Uh, so let's just see. So the first step in order to calculate this is to get 47. We want to calculate negative 47. So first step, let's just see what 47 looks like in binary. So what is 47? It's odd. So I know that the first bit is there. So after that, it's what 46, right? 46 is essentially. So this is how I look at these conversions. So I have 47 over here. So the nearest 2's power is 32. Subtracting this, we get 5, 15. So this is more than 16. But sorry, this is less than 16, but it is one less. So directly we can just do 1, 0, 1, 1, 1, 1. Okay, so this is essentially 47. Now this is 16 bits, so we just have it like that. Yeah. So now we want to convert this into negative or 2's complement we want. So do you guys know about the trick to getting 2's complement? Okay, so there's a trick to getting 2's complement like this. So the trick is very simple. Firstly, we'll just invert everything. Okay, so we have inverted everything. And after that, we'll just add 1 to this. So we have and 0, 0, 0, and finally 1. Okay, so this is the 2's complement. The reason that this is 2's complement is because if we add this and this together, then it will basically overflow. So this is an explanation for the 2's complement and why it is considered the negative number. So what is a negative number? Can I say that a minus a equals 0? Then minus a is negative of a, right? Or let's just put it like this. Let's say a minus b is equal to 0. So what does this tell me? Essentially, a plus min minus b. Oh, sorry. I'm getting confused. A plus b is equal to 0. Then b is equal to minus a. So far, you guys understood, right? So if we are adding two numbers and the resultant is 0, then we can say that the second number is the negative of the first number. Is that correct? Can one of you guys actually unmute and you know react to what I'm saying so that I understand whether or not you guys are getting this one. Okay. So we have a plus b, a plus. So we are adding two numbers, and if the resultant is 0, in that case, we can conclude that one number is a negative of the other. So let's just add the both of these and see what happens. 0, 0, 0, 1, 0, 1, 1, 1, 1. Yeah, so this is essentially what we have. So let's add this and see what we get. So 1 plus 1 is 0. So we get 1 carryover. This is also 1 plus 1. So that is 0. We get 1 carryover. 1 plus 1, 0, carryover. 1 plus 1, 0, carryover. So like this, we'll keep getting 1, 1 carryover. Okay, so it will result in a number that looks something like this. And the final carry will be outside. So essentially, what we are trying to do in 2's complement is that we are trying to overflow the data that we have. So let's say that this is 16 bit. So we are trying to overflow the bit so that the final bit, the final one, goes to 2 to the power 16 or the 17th bit. So these are the 16 bits of information that we can read, and this is the overflow bit. So this one we cannot read. This is essentially like an extra piece of data that is not usable by us. So when we read the data that we can read, we get 0, right? So adding to both of these together, we are getting 0. Hence, that's why we say that the 2's complement, so this one, can be represented as minus 47 and this is plus 47. Is that clear? And if you guys want to like calculate the long way, like calculate 2's complement the long way, then we can just take this one and then subtract, let's say, the same number. So we have 47 over here. So let's just subtract it. Okay. Now, subtraction in binary may look a bit complicated as compared to subtraction in normal decimals. But let's just see what happens. So we have zeros all the way over here. So it's best if we just take one over here, right? So how will we take one over here? We'll have to carry it from all the way over here, right? So what will we get? It is 1, 1 0 over here. So if we subtract, it will become 0 1, and the like, it will keep going. So this will become 1 0, whatever. Eventually, it will come over here. This will be 1, and if we just subtract this one from it, we'll get 1 over here, and then all of these will be considered as 1. So essentially, like what we are doing is considering this as 1 0. Okay, so sorry, I'm not able to explain this properly, but essentially what is happening over here is we are taking this whole thing as one number, right? So what will happen if we subtract 1 from it? If we subtract 1 from it, it will become like this, right? So this is what will happen if we subtract 1 from this one, right? So the first number that we are subtracting is 1. So essentially what will end up is 1 over here, and the rest of the numbers will be like this. Now since everything is 1, we will either get 0 or we will get 1. No need to worry about the uh, 0 minus 1 issue, because everything is now 1. So we can just directly subtract this one. So it will become like this, and after that this is 1, so it will remain as 1. This is 1, so it will be subtracted. uh, and then 1 1, and finally it will be like this, and the final bit will be 0. So notice that this is the same answer that we got. Although it is a bit complicated to reach over here, you'll have to subtract from the this number. But once you do that one, it is not that tough to do. It's really quite simple and logical why we are using two's complement and how we are getting two's complement. So this is essentially like what we how we derived of two's complement. But this is a shortcut. I took too much time on that one. So let's just move on to the next question, shall we? Okay, so the next question is a hexadecimal one. So can you guys just give this a try? The number that we have is D937A. One recommendation that I'll give, we are supposed to get a 16-bit binary representation of this number, right? So the first thing that you want to do is, since this is a hexadecimal number, each of the digits, okay, so D937 and A, all of these can be represented with 4 bits each. Okay, so one correction that I'll have to make with this one, it is that this is a 20-bit binary representation, not a 16-bit. Okay, so every single digit over here, it can be represented using 4 bits of data. Okay, so your task is to find what 4 bits is defining each of these uh, hexadecimal digits. Okay, so I'll give you right now is what 644. I'll give you till 650 to solve this one. If you're done, just raise your hand. Okay. Okay, so I see that Said is done. Are any others done?
Yes, sir.
Okay, so let's just solve this together. Can any one of you, like you guys, just put the answer that you got in the chat? Okay, we'll just confirm this later on. Okay, so what we can do over here is firstly since reading hexadecimal is a bit difficult for us, we can just directly convert these into decimal numbers so that we understand what we want to read. So 9 is 9, 3 is 3, 7 is 7. That much is clear. A is actually 10. Okay, I hope you understand why A is 10. D is So, firstly, let's go from right to left. So, 10, we already know it's like 6 plus 10. Sorry, 4 plus 4 plus 8 plus 7. It is simply 4 plus 3. So, 4 plus 2 plus 1. So, it is this. After that, we have 3, which is 2 plus 1. After that, we have 9, which is 8 plus 1. And finally, we have 13, which is 8 plus 4. Uh, yeah, 8 plus 4 plus 1. So 8 plus 4 plus 1. Right? So that's the answer. So we have 1101, Okay, so let's just move to the next question. Um, okay, the next question, I think it would be "हो आगे झुके थी जुबान में इश्क की लगन में कैसी कैसी बातें हो गई." Yeah, sorry about that. The internet issue is quite tough over here. Um, but yeah, so we have this one. So essentially, we want to, I believe, uh, write a code for this one. So I believe. So you guys might have seen REST 5 and stuff like that. So firstly, we have this one. So firstly, we have this one. So load is 00, store is 01, and is 10, the next 8-bit essentially just gives us the value from 0 to 15. I think that we can extend this also if needed. So this is the next Yeah, sorry about that. I guess the network issue is a lot deeper than I expected. Um, but yeah, coming back to the coming back to what I was talking about. So essentially, what we want to do is that we are given instructions on how we can encode the data. So we want to write 11 or R911. Okay, so how can we do this? We have operand 1, operand 2, and the total should be 18 bits. So we can just Okay, seems like the network issue is too much. Uh, so I've just written down this one. Can anyone explain to me why this works? Okay, so can is it okay now? Can you guys hear me?
Yes,
Okay. So on screen, I have written down the solution. Can you just explain why it is like the solution? Why is it correct? Okay, so this is not even the final answer. The final answer is something else. It is asking for the hexadecimal representation. This is currently the binary representation. So, can anyone tell me how we can just quickly and easily convert this into hexadecimal? Okay, so I'll just explain really quickly before the network disappears again. To convert this from binary to hexadecimal, since it is 18, okay, it is not a multiple of 4. We are just assuming that there are two zeros over here. Okay, so after there are two zeros over here, we can just convert this. This is 3, this is 111, this is
Voice is too much
your
lagging.
voice is breaking.
111, this
So you are not audible.
I'll see if it's possible, but I think it would be better if we just end the session. I,